Dignitaries on the dais, off dais, ladies and gentlemen, a very good morning to all of you.
Good morning.
Of course, I wish this hall were a bit smaller or there would be more people over here. The topic for today is quite exciting, machine-to-machine communication. It has fired my imagination when I was a young student. And one of the topics I took up for my, seminar work over there was cybernetics. That is how it all started. And in cybernetics, I was excited to find some of the Russian engineers. They had calculated, the relationship, corresponds between the electronics and the human body. And for brain, they mentioned that if at all, with the technology which was available in the early 60s, that's the tubes, the size of the human brain would be of the size of Empire State Building of United States, which was the tallest building at that particular point of time. And since it was tubes, a lot of heat would be generated, and so it would need cooling also. So it will need Niagara waterfalls to cool it. So this all was exciting. And I actually wanted to sort of enter into this domain. But at that particular point of time, I'm mentioning in the 70s, there were no possibilities of doing any work over here. And I wish Chris Gopalakrishnan were born 30 years back, 30 years earlier, then probably I would have had some opportunity of working on that. Anyway, that's past. But this has remained on my mind all the time. And there are many things that keep interesting me, like telepathy. There are many people who may not have any faith in telepathy, but the fact remains that it has been found, there is scientific evidence that it happens. And it's a brain-to-brain communication, and brain is a machine. So this is something which definitely has inspired people in a big way on this journey towards M2M. In fact, if we go back into our past, we are aware that Bhagavad Gita, that narration happened with, by Sanjay, who was sitting hundreds of miles away from the battlefield. He narrated the whole thing to Dhritarashtra. Now, it's neuron-to-neuron communication. And we are aware nowadays that neuron is like a smart chip in the brain. So there are so many things which point towards the direction that in nature at present, there are already machine-to-machine communication happening. We travel on the highway, and if we are not aware of the cameras which are there, hidden cameras which monitor our speed and can take pictures of our, the number plates, we would be driving at any speed in any way. But when, finally on these highways, some of the people receive, penalties for having crossed speeds, then you realize, oh, there were radars there taking note of it. Same thing happens to us at a macrocosm level. We wonder, we feel that when we commit some sin, something, so nobody is seeing us, but we can see the effect of it later, that we have to pay for it. And it all happens with machine-to-machine communication. Somebody may find it funny, but I'm convinced about it that it actually is a very advanced system which will take many more years to reach that level. Now, so far as my experiences are concerned, when I was into mobile communication about a decade and a half back, at that particular point of time, there were a lot of things happening. It was new in the country, And many people said, let us have a seminar on applications and all that. And that's where my interest into this started. I noticed with my study that many countries are already in an advanced stage, like, for example, in Australia, for the infrastructure, to protect infrastructure, the way they are using this system is amazing. Like, there are creeks across sea, and these creeks are susceptible to corrosion. Now, what they have done is, and it's due to deposition of anions, so there is a monitoring, and automatically, when the levels cross a particular threshold, cations are released into that particular domain, and they neutralize this and prevent, corrosion formation. So this happened a decade and a half back. So people are working, in fact, monitoring of roads, monitoring of flyovers. There have been collapse of flyovers, but if it's properly monitored, the strain is monitored. There is every possibility of preventing that, because when the stress on the bridge exceeds a particular point, it loses its resilience, and then that's where the collapse happens. But if it can be monitored continuously and, preventive action can be taken the moment it crosses a particular threshold. So there are n number of applications, and this was how I got interested into this again, prevention of disasters, of building collapses and other things, that all can be handled with the help of machine-to-machine communication. There was another thing that happened to me around the same time when I used to deliver talks on mobile communication, its applications and special applications. Some organization approached me, why not we work on the unmanned ground vehicle? So for that, they said, communication is a big challenge. So I said, use 3G service. When they narrate, and I said, GPS and 3G service. They said, yeah, we have tried this. But the fact remains that when you have an unmanned vehicle, which does not move on the road, it's on the rough terrain, maybe near the battlefield. So you can't expect an even surface. So there have to be cameras, there has to be a feedback, and then, the direction of the vehicle can be altered automatically. So that is how talk about 4G networks started at that particular point of time, more than a decade back, that there has to be some such system which can sustain a bandwidth, which can take, this type of, application on that. Similarly, a few years back, about 4 years back, I delivered a talk on tele-education, telemedicine in Ghana. It was, in fact, it was a telemedicine session arranged by WHO in Ghana. So there, when I talked about telemedicine and what we had done for the Pan-Africa, a gentleman from Nigeria stood up and he said, yeah, it all looks beautiful, but tell me, why are you sending fake drugs to us from India? I had no idea. And the shocking thing is that even the ambassador of India to Nigeria was present. He also did not react. So when I came back, I just did a study on this and realized that yes, fake drugs are being manufactured in India, are being sent to Africa, but not from India. They are all made in China with labels of made in India, and they are sent there. They get money and we get the boot. So then we started working on a non-clonable ID. We have a partner who already had this patented chip, and it can track and trace the particular pharmaceutical product right to the source. And it cannot be cloned, because you'll notice that when you have a pharmaceutical pack, there is a barcode on that. That barcode, you can just simply take a Xerox of it and fix on everything. So it is clonable. But this particular product it's based on some silica, random process. With the result, it cannot be cloned. So here, machine-to-machine communication is possible because authentication and track and trace can happen. Even if it's in Ghana, they can track and trace back where it was actually manufactured, and that's how action can be taken. So this concept further extended during the Commonwealth Games to Delhi Police. Delhi Police, had a challenge of suicide attacks. They thought that during these Commonwealth Games, definitely there'll be some suicide attacks, and there has to be some mechanism for preventing that. To take care of that, there was a small non-clonable chip put on the eye cards. So what in this case happens when the squad, of course normally all these suicide bombers wear dress of the police or army. So when they approach a particular barrier, there all their eye card is monitored. This eye card displays actual facts, details about the person to whom this eye card was issued. The photograph is not so important. It's the details which will also display the photograph which was taken at the time of issue of this. So at the same time you have CCTV cameras. So the person sitting at least a few hundred meters away knows, yes, it is the same, it tallies. So if it does not tally, they can blow up the vehicle itself. I mean, that is how during the Commonwealth Games, everybody was aware of this, and no such thing happened. So there are many things, many applications that this machine-to-machine communication would enable. Starting from the environment itself, there is a lot of potential. We have challenges of air pollution in Delhi. Recently, there have been reports of Delhi being the most polluted city in the world. I mean, maybe after Beijing, or maybe some people say more than Beijing. So if that quality of air can be monitored, action taken, to prevent, automatically, there are many things that can be done. The gases can be controlled in an automated manner so as to neutralize some of the gases. Similarly, water pollution control, hazardous industries, and prevention of flora and fauna from vanishing, that also can be done. People are using these devices for tracking animals, tigers, and other people. It's already on, nothing new. Similarly, for disaster management on coastal areas, automated, warning systems without human intervention is possible on seismic zones, mines, and the bridges and flyovers I have already mentioned. Similarly, there are a lot of applications in health. I mean, I supported a project about a decade back called, smart ambulances. In that, we put, all these monitors for heart rate and other things, all the instruments, and at the same time, through mobile network, there was a server in the hospital. It would communicate with that. Now, if there is a patient who's seriously ill, his parameters from his home to the hospital can continuously be monitored in the hospital by a specialist. And he can advise the paramedic who's attending on him what to do. Because there are many cases where the patients reach hospital in a dead condition because en route they are not taken, it's not possible to take care of them en route. So, but there was a big challenge in this. I was told in those days, yeah, then you need a separate, ID for every one of them and separate IP address for all of them. So for each device, for each hospital, so it's going to be a big number, and where are the IP addresses? So fortunately, there has been an evolution here as well, and now with IPv6, these type of challenges can be addressed. Similarly, it's possible to handle epilepsy patients. Because if in the beginning itself, when there is a build-up in the brain of some order, if preventive action is taken, so it is possible to even prevent epilepsy. So there are many applications, can't go into details. And similarly, for home automation, that was another fascinating thing, wherein the ladies could control all applications from home. And of course, from office, when you are on the way, you can switch on your air conditioning, you can switch on the washing machine or whatever. Even cooking can be done en route, and when you reach there, everything is done. Similarly, because the big challenge we face is water, and it's possible to have drip irrigation, to prevent a lot of water wastage, which can happen based on the temperature and the moisture conditions. It's not necessary to waste water just like that. So it can be in an automated manner. Similarly, we are entering into many domains, including manufacturing. Now with 3D printing, it's such an exciting area where so many things can happen with this machine-to-machine communication. Power, smart grids, smart metering, security. Those of you who must have seen the serial 24 must have seen how all these things happen. For defense, I have talked about the unmanned vehicles and automated reconnaissance that is possible with this. And Siachen, it's not physically necessary for our soldiers to be there and get maimed and killed. It can be done remotely, and in case of emergency, they can be dropped over there. Transport. Nowadays, as was already mentioned in the opening, session, Mr. Kalyan Sundaram, that so far as the vehicle, the automotive industry is concerned, it's coming in a big way. And even Mahindra Reva, I was told that it's having a lot of features of machine-to-machine communication. And, it's possible to forewarn the driver if there is any challenge with the vehicle. We don't know, on the way, sometimes the brake fails, sometimes some other problem happens with the engine. But if there is already a communication happening between the central, control unit and the various components of the vehicle, so advanced action can be taken and major catastrophes, accidents can be prevented. There are so many things happening, even about it's possible to sort of take car-to-car communication. If there's a vehicle coming from the other side, the two vehicles can communicate whether the traffic from the other side is high, so you can decide which direction to take, or that direction also can be given to people that this is congested, you take a road which is lesser congested. In software coding also, software industry, there will be a big application in this. Right now, what happens is somebody develops a software offshore, onshore, then there is an iteration, correction. But with this, it's possible to do that code correction in an automated manner. And it's started happening. All this looks good, but there are a lot of challenges also in this. One is, of course, the frequency band. There are talks about 5G. We are talking about 30 gigahertz being used for all these applications, but still, it's in a nascent stage. The work is going on. IP addresses, probably with IPv6, they'll be resolved. There are standards. Thank you. There are standards, and developing of the entire ecosystem is critical for this to take off. There are many standards which are already in practice and happening, but fine-tuning and specifically, for a country as large as India and with developing country like India, where there will be more such applications, finally, because we have to leverage technology for many things for which the Western world or the developed world already has solutions. We have to look for them also, whether it's health, education, and everything. So, basically the technology has to be open, modular, and of course extendable. There's no doubt about it. This machine-to-machine communication is going to touch our lives in a big way. I'm confident about it. And it's going to transform the way we do many things, including business. And I feel 2020, we can see a major change. And if it's a conference like this, we'll be discussing something else. Thank you very much.